Welcome you to Lecture 5 for College Algebra. My name is Jorge, and in this lecture we're going to be talking about the distance formula and the midpoint formula. So there's two objectives. First, of course, the distance and then the midpoint formula. So those are the two things we're going to do in Lecture 5. There are two parts to this lecture, so there'll be two videos. So the first thing that I want to introduce is something that you've seen before. This is what they call a rectangular coordinate system, Cartesian coordinate system, or an X and Y plane. And so there's different components to an X and Y plane. And the first one is that the vertical axis, or is known as the Y axis. And then the horizontal is known as the x-axis. Now, the origin would be where the ordered pair is 0, 0. So here we have another coordinate plane. And so we're going to go ahead and plot the point 6, 4. So when we plot a point, the points are going to be, they're always going to be x, y. So the first thing that we do is we go left or right in the x-axis, and then we go up and down on the y. So for 6, we're going to start at the origin. And what we're going to do is we're going to start at the origin, go to 6 on the x, and then go up towards the 4. So the point 6, 4 is the point in purple there on the screen. So the next thing is we're going to go ahead and plot the point -3, -5. So again, we're going to start at the origin. We're going to go to the left to -3, and then from -3 we're going to go down to -5. And that's what this looks like. Okay, so the next one that we're going to plot is we're going to go ahead and plot the point 0, 7. So again, we always start at the origin. We do the x first and then the y. Now 0, 7, we stay at the origin, and then we just go up to 7, and that's the point 0, 7. And then the next point that we're going to plot is the point -6, 0. Again, we start at the origin. We're going to go towards -6, and then we're going to go ahead and stay there because the y coordinate is 0. And that's what it looks like. So the next thing that I want to talk about is the quadrants. So in an x and y plane, we have 4 quadrants. So the first one is quadrant 1, and here both x and y are greater than 0, so they're both positive. In quadrant 2, your x is negative, so it's less than 0, and your y is greater than 0. In quadrant 3, they're both negative, so x and y are both less than 0. And then in quadrant 4, your x is greater than 0, but your y is less than 0, so therefore your y is negative. So now let's talk about the distance formula. And the distance formula says that the distance between 2 points P1, which has coordinates x1, y1, and P2 with coordinates x2, y2, denoted by the distance P1, P2, is given by the square root of the difference squared of your x coordinates plus the difference squared of your y coordinates. So here we have the first example. So we're going to find the distance d between the points 1, 3, and 5, 6. So here we can see in the graph the point 1, 3, and then 5, 6. So we're going to go ahead and find that distance. So one way to do it is to draw out a right triangle. And using a right triangle, then we can go ahead and use the a squared plus b squared equals c squared formula. So in this case here, we get that d squared is going to be 4 squared plus 3 squared, which is equal to 16 plus 9, which is 25. So the distance squared of the line segment D is 25, but then we find the square root of that, so we get 5. So the distance, or the length of the line segment, of distance between the point 1, 3, 5, 6 is 5 units. So the next thing that we're going to do is we're going to go ahead and find the distance between the 2 points, 2, -4, and -1, 3. So we're going to go ahead and use the formula. And so here's the formula. So what we're going to do is just go ahead and plug in all of the two values that we have. So -1 minus 2 squared plus 3 minus -4, and then we're going to go ahead and square that difference. And that's going to give us the square root of -3 squared plus 7 squared. And then of course that's going to give us 9 plus 49, which is the square root of 58. And then we can go ahead and round that to 2 decimal places, which is approximately 7.62. Either one of those two, square root of 58 units or 7.62, is acceptable. So the next thing is we're going to talk about three different points, and we're going to consider the 3 points. We have A, B, and C, and then we're going to plot each point, and we're going to form a triangle ABC. And then what we're going to do is we're going to go ahead and find the length of each side of the triangle. So here's the triangle. So we have point A has the coordinates of -2, 1, B has the coordinates of 2, 3, and C has the coordinates of 3, 1. So now the first thing is we're going to go ahead and find the distance between A and B, and we'll go ahead and find those values, and that distance gives us the square root of 2 or 2 square roots of 5. Now the distance between B and C is the square root of 5. And then the distance between A and C is 5. So the next thing that we're going to do is we're going to verify that the triangle ABC is in fact a right triangle. And so here's the triangle again. And then here are the values. So we know that the distance of AB is 2 square roots of 5. The distance of BC is square root of 5. And the distance of AC is 5. So then if we use that information and we square each one, then we get that 2 square roots of 5 squared plus square root of 5 squared should equal the distance of AC squared. And we find out that in fact it is. And remember that the area of a triangle is 1/2 the base times the height. So 1/2 times 2 square roots of 5 times square root of 5 is 5 square units. So this is in fact a triangle, a right triangle. Okay, so the next thing that we're going to talk about is the midpoint formula. So here we have 2 points. We have P1 with coordinates x1, y1, and then P2 with coordinates x2, y2. And then we have the line segment M, or the midpoint, which is xy. So then also notice that we have a point A and a point B. A point A and a point B, and we're going to use all of this information in order to derive the midpoint formula. So the first thing here is that we have that x minus x1 is equal to x2 minus x. So in other words, that the distance between P1 and M is equal to the distance between M and P2. So then we can go ahead and use some algebraic manipulation to find out that x is in fact equal to x1 plus x2 divided by 2. Now we can do the same thing with the y, and so the distance between y1 and y2 is, so if I were to divide that in half, so the distance between y1 and y is equal to the distance between y and y2. And again, we derive the same formula. So here's in a more formal setting. So the midpoint M with coordinates xy of the line segment P1 to P2, so P1 is x1, y1, P2 is x2, y2, is simply the average of the x coordinates and the average of the y coordinates. So here we're going to go ahead and find the midpoint of a line segment from P1, and P1 is 4, -2 to P2, which is 2, -5. Then we're going to go ahead and plot the points in the midpoint. So here's the 2 points plotted in the midpoint. So we know the midpoint formula. So then the first thing is we're going to go ahead and find x, and x of course is x1 plus x2 divided by 2, and that gives us 3. And then we're going to go ahead and find a y coordinate, and that gives us -7/2. So the coordinates of the midpoint for this particular example is 3 and -7/2. And that's the end of lecture 5 part 1. Thank you.